Join ForumIAS Academy, trusted by hundreds of toppers, including IAS Rank 1 Shruti Sharma.
So I think हम कर रहे थे एटमॉस्फेयर ना, लास्ट आई थिंक एरोसॉल लिख लिए थे ना आपने, ठीक है। So atmosphere, we started with the what is the definition of atmosphere, है ना? So in that we saw कि this is nothing but an envelope, gaseous envelope, which is surrounding the earth because of gravitational force, ठीक है? So with this we also understood there are certain elements which are found here. For example, various gases, then water vapor, then dust particles. Okay? So now, after discussing all these things, now we are going to discuss what is the exact composition of our atmosphere. Okay? So atmosphere is divided on certain basis. Number one, if we divide it on the basis of chemical composition, so the layers can be divided into, let's say this is the surface. The first layer is going to be, which is the first layer? If I look above with, yes, so the first one is troposphere, then second, strato, very good. Then meso, very nice. Then thermo, ठीक है, हाँ, iono and exo. Actually, this is nothing but the part of this thermo, है ना? Iono and finally exo. Now, based on chemical composition, first देखिए. Now, based on this composition, we will divide this into two. One is homogeneous and the second is heterogeneous. What is homogeneous? Yes. Yes. So, what is the difference between heterosphere and homosphere? Yes. So, what is the difference between two is the constituents in this much of homogeneous layers are almost, or we can say more or less, they are same. For example, in this much of the environment, you will find nitrogen is around 78%. Okay? So more or less composition would be same. So this is how we divide this one based on some chemical composition. Okay? So write down. The atmosphere can be divided into based on chemical composition. This is not the chemical, this is not the chemical based classification. This is temperature and pressure based. This one in red is your chemical composition based classification. This black in color is showing you temperature and pressure based classification. Have you started reading newspaper continuously? Yes. So which cyclone recently hit Indian Ocean? कौन सा cyclone था? Yes, recently. Which was the cyclone which not only originated in Indian Ocean, but also it was the one of the most, we can say, most of the records have been broken because of the cyclone. What is that cyclone? ध्यान से पढ़ो न्यूज़पेपर, ठीक है? You are missing important information. This is important. Go back and read about this cyclone. Cyclone named as Freddy. Have you heard this one? Freddy? F-R-E-D-D-Y. Okay? So, read current affairs and your newspaper very properly. Important one. Now, you have written, based on the chemical composition, atmosphere can be classified into homogeneous and heterogeneous. Homo means, right, homogeneous means the proposition of gas composition. Proposition of gas composition is more or less similar in this layer. Proposition of gas composition is more or less similar in such layer. For example, nitrogen would be around 78% in this all layers based on homogeneous classification. Okay? For example, in this one here itself you can write, let's say nitrogen 78% in almost in this layer. Okay? So more or less similar. Somewhere you will find 77 point something, 78 point something, 76. So almost that is similar. The second is the next classification. The classification based on temperature and pressure. Temperature and pressure. Make this wala diagram. You have already made na. Okay? So we will now understand this chemical is over. The second one is based on temperature and pressure. Yes. Yes. Composition would be somewhat different. Okay? Somewhere you will find nitrogen is, let's say, 70. Somewhere you will find 60. Somewhere 50 in this way. Okay? So hetero means different in chemical composition they are. Okay? So temperature and pressure, this is important not only for your prelims. Okay? बहुत important है. And also it is important for your mains. Okay? Indirect questions you will be asked in mains. Let's start with the first, some of the questions. Let's say this is equator and I assume this is your pole. Okay? Now if I ask you where the gravitation force would be max, not gravitation force, tell me where the convection would be strong. What is convection? Yes. So this is nothing but, I already told you, if the vertical transfer of energy is going on, or I can say this is nothing but the process of convection. So tell me where you can find very strong convective forces, on equator or on pole? Equator or pole? Why pole? Shorter distance. What is convection by definition? Tell me what is convection? Yes. Transfer of heat. So we are talking about pole now. Pole पे transfer of heat कैसा होगा? Strong या फिर weak? Weak or strong? Weak. So can I say the convection would be very strong when it comes to equator? Yes. Why? Because our surface of this area near equator has high temperature. So if I talk about equator, the temperature near equator is high, and therefore whatever the horizontal wind comes in contact with this area, what happens to this air pocket is this will start rising above. Why? Tell me why. If it is getting some heat, why it is going above? What happens with this one? Gravity कम है? No यार. Now, I already mentioned this topic, I think on Saturday we also discussed this phenomena. है ना? Tell me now. Why when when air is coming in contact with this hot surface, why it is rising? Sir, it is thin. It is thin, no? Anybody? Yes? Anyone? why, if it is warming, why it is going above? What happens to this air? Why it is going above? Yes, exactly. Air is by nature compressible. Okay? By nature, air is compressible. Means because of the gravity, let's say if you have compressed this air near the ground surface, let's say this is your ground surface. If I have compressed this air, okay, but now what I am doing is I am just giving some energy to this compressed air. Now what happens with this air? Remember two things. One is now because of this energy, what is going to happen? The particles of this air are now going to expand in size. This is one thing. The second thing is because air is a poor conductor of heat. Okay? So the only method which is there with this air particles is nothing but transfer the heat by moving itself. समझ में आया? With the movement. Okay? समझ में आ रहा है? The first thing is we have certain processes of energy transfer. One is, understand here, one is radiation. What is radiation? Means some indirect energy has been transferred. Okay? For example, from sun to earth. Okay? That is radiation. The second is conduction. What is conduction? Conduction means the particles are connected together and from this side to this side the energy is being transferred. That is conduction. The third process is convection. Now what is convection? Convection means vertically some particles are moving away and in that process they are transferring some heat. So if I ask you, the convection type of transfer of the energy is possible in case of land. Tell me yes or no. In case of land, convection is possible. Land में how land can move somewhere else कि भाई ये लो ज़्यादा heat है? No, नहीं ना. And about water, convection in water is possible. Yes, and that is one reason why land will become warmer at a faster rate. Because it cannot move to transfer its energy. Whatever the energy land is receiving, land has only two methods to transfer that, radiation and conduction. This method is not available to the land. Land cannot move to transfer its excess energy to somebody else. समझ रहे हो? India cannot transfer its energy to Africa. Let's say, भाई ये लो. Possible है? No? And that is the reason if I compare land and water with the same amount of energy, land will be heated up very soon. Water will transfer its energy to other water particles. ठीक है? Air can transfer this energy to other air particles with this process of convection. Now in this air, this conduction is very rare, or we can say the conduction is very slow in case of air. Why? Because it is a poor conductor of heat. समझ में आया? So what happens here? Just understand, air comes in contact. Let's say this was horizontal wind. Wind came in contact with the very hot surface. With this hotness, with this temperature, this is nothing but kind of energy source for the air. Now air has been warmed. The warm air is now expanding. Why? Because it wants to transfer its energy. Number one. Why it is expanding above? Because of its energy. So because of this energy, this air is now not only expanding, but also it is cooling down. समझ में आया? In the process of this temperature, let's say the temperature here was 27 degree. Somewhere after 1 kilometer, कितना हो जाएगा? Tell me, 6.5 exactly. So what is the temperature? 20.5. ठीक है? So the temperature would be around 20.5. So in this process of upliftment, not only this is transferring the energy, but also you can see now this energy. How much energy? 6.5 degrees centigrade has been provided to the atmosphere. This amount of temperature has been reduced to the air pocket. Why? Because now this energy is with the atmosphere. Okay? We will understand in the due process of our classes how this energy is transferred. समझ में आ रहा है? Now tell me one more thing. Let's say if I say that this temperature is very, very high, can I say this convection would be strong? Yes or not? Yes. So in case of equator, this convection would be strong. Yeah, in case of polar area, this convection would be strong. Obviously equator, because the temperature is very high on the equator. Yes. So just understand, this is the one thing that you have to remember. Now if I talk about troposphere, tropo is nothing but, by its meaning itself, it says the mixing of air. Tropo means mixing of air. Okay. Now, how this mixing of air is going on? If I tell you this troposphere, let's say this is the surface. Okay, this is the surface. From this much of the distance, this vertical transfer of air is going on. समझ में आ रहा है? And in this way, I can say the mixing of air is going on between surface to this much of the height. Everybody? So this is nothing but your troposphere's height. Okay? Now troposphere's height varies from 6 kilometer to 16 kilometer. Or in some books you will read this height of troposphere varies from 8 kilometer to 18 kilometer. Now tell me how this is possible. Somewhere the troposphere is of 8 kilometer height and somewhere it is of 18 kilometer. Tell me. Yes, exactly. What happens here is, just understand. So if I talk about troposphere, let's say this is equator, okay? And let's say this is pole. Now what happens is, over this equator, because of the strong convectional current, this air can vertically rise up to how much kilometer? 18 kilometer. So this is the vertical rise of air over equator. But when it comes to the polar area, this vertical rise is only limited up to 8 kilometer. Okay? So in this way, if you will see from this side, you will always see this is the height of troposphere. Can you understand now? This is one pole, this is another pole, and again the height of this is 8 kilometer. So over the equator, you will always find the greater heights of this troposphere, and over the polar area, you will always find the lesser heights of troposphere. Just by this definition of troposphere, you have to understand this is the layer up to which air can be convected above or can be lifted above. After this, there is no mixing of air. Okay? Now, can I say that there is some lid? Lid means, everybody, what is lid? Bottle ka dhakkan. Now, can I say that there is something which is lid-like phenomena which is actually preventing such vertical upliftment of air? Or can I say this is the lid which is actually preventing this vertical upliftment of air? Yes? So, can I say this is nothing but putting a pause on what? On mixing of air. So this is the region. Mixing of air is what? Tropo. So can I say that tropo has been paused in this lid? Yes. So this layer is known as tropopause. Everybody getting now? So what happens is, over the equator area, this vertical upliftment would be up to 18 kilometer. It is possible. Now, after 18 kilometer, what happens is, there is a kind of lid mechanism which is actually pushing this vertical upliftment of air somewhere down, and that is the region. Now here it is a pause, and this region is known as tropopause. Means the mixing of air has been now paused. Everybody? So this is the reason why mixing of air is limited up to 18 kilometer at the equator, and around 8 kilometer kahan pe? Over polar regions. Okay? And that will decide the height of troposphere. So this is nothing but you can make this diagram. This is your height of troposphere. This is your tropopause, this layer. Let's say 5 kilometer above. Troposphere. mixing of air, a stop here, or can I say no vertical movement of air? So this tropopause is characterized by 5 km above this troposphere. This is nothing but working as a lid mechanism. By this lid, you will not see any vertical movement of air in this zone. Okay? The second is this mixing has been stopped, and that is the reason it is known as tropopause. Done, everyone? Yes. हाँ, yes. See what happens is, यहाँ तक समझ में आया कि over this equator zone, because of the intense heat, ठीक है, what happens is up to 18 km you will see the air can rise. But this is not possible in case of polar areas because the amount of heat is not there. So this upliftment can go up to, let's say 6 or 8 km. Let's say 8 km. Now from this 8 km, this is also polar area. This is also 8 km. If I draw a kind of surface, I have seen this phenomena that is nothing but a troposphere. Over this troposphere, this vertical rise of air is not possible. Can I say there is nothing but a pause mechanism? Yes. So this pause is actually preventing further vertical upliftment of air. And in this way, it is working as a dot or a bottle's dhakkan. Okay? So this is nothing but your tropopause. Why tropopause? Because mixing of air has been paused. Okay? No. It is because of what? It is only because of... Yes, no. It is only because of this vertical pressure or this vertical force. So convection is powerful up to 18 km. Now we will understand. Abhi aane do cheezon ko. One more reason is still left. हाँ बोलो. हाँ. Mixing of air matlab this is warm air na. Above layers are somewhat cooler. Now this warm air goes above, means what? This is mixing with the colder air. This is mixing of air. ठीक है?